Today we are here to test our system. Today we are testing the full functionality of the system, including detection of scuba divers and detection of submerged mines.
Our project is named Autonomous Platform for Securing Marine Infrastructures, and it receives support from the NATO Science for Peace and Security Initiative. This program brings together NATO countries and partner countries to work together on a well-defined set of research topics. And in particular, we have in this project Spain, Israel and Canada working together on the design and the prototyping of advanced technologies for the protection of underwater installations, including energy installations, as well as on the detection of submerged divers and mines.
We mounted our modem, our own AUV, and we deploy the AUV at sea in a relatively shallow area of 70 to 80 meter depths. The AUV is performing a fixed mission while scanning the area to find suspected targets. Once a target is found, the AUV is changing its task, moving around the target to see it from the other direction, and then sending us a picture using its underwater acoustic modem that we placed on it. The AUV is 6 meters long, it weighs almost 1 ton, it has 2 synthetic aperture sonar from both sides and 1 forward-looking sonar. There are also HD cameras, and we have full accessibility to all its sensors. We have our colleague from the University of British Columbia here doing experiments on the underwater acoustic communication system. We have the students who developed the algorithms for the target detection from the sonar systems, and we have our own operators of the AUV. This is a very important experiment for us because it checks the functionality of our system in real conditions. The sea here has lots of rocks and sand ripples, which makes it very hard to find a target like the submerged mines that we are aiming to find.
In this project, we collaborate with our colleagues from Spain and Israel and develop robust underwater acoustic communication methods. By robust, we mean that communication is resilient to ambient disturbances such as acoustic noise from ships and other sources experienced in marine infrastructure environments such as harbors. We apply methods from source identification and sparse signal detection to effectively cancel those noise signals and retrieve the actual communication signal. We are testing our methods on real data and in sea trials. This research will contribute to the overall project objective of securing marine infrastructures.
Are you ready?
Yes, I am ready.
So my name is Lazar, and I'm from the University of British Columbia, currently doing a master's degree in applied science. In the underwater sea environment, you can't approach it in the same way of using electromagnetic waves. So we use acoustic waves, and in fact, this is actually a tricky thing to accomplish, to achieve robust communication in underwater using acoustics. Of particular interest for us is interference, and in shallow water environments specifically, you get a lot of interference from shipping noise and shipping activity. And the goal of our project here is to actually try to suppress this interference. We've had so far pretty okay results regarding time series methods for suppressing interference, and now we're gathering experimental results here at the sea trial.
Our solution for detecting of scuba divers rely on complex signal processing techniques. We transmit active acoustic signals, get the reflections back, and from the reflections we understand if there is a mobile target in the water.
We distinguish between reflections of a scuba divers than reflections from a school of fish by the pattern of the found target. To find submerged mines, we use autonomous underwater vehicles, or AUVs.
IMDEA Networks is the Spanish partner of this project and focuses on the design of novel techniques for the localization of underwater devices. We work along two different lines. On the one hand, we exploit vertical arrays for the full 3D localization of submerged entities. And on the other hand, we localize mobile targets in a very constrained scenario where we have a single receiver and need to leverage knowledge of the surrounding environment in order to know where the target really is.